Hi, my name is Ken Asselson. I've just recently enabled custom bacteria or taxonomy selection for a lovely bit of data which is coming over from the GMRepo curated database of human gut genome, which has approximately 71,642 samples in it. And these are curated, that is, there are certain bacteria, certain medical conditions diagnosed with it. So it's a nice set. And what I'm going to do is I'm going to go over here and log in, and here we have somebody with the characteristics here and sorted. So what I'm going to do is I'm going to go down and let's pick one for the moment, and actually I'm going to change the number, and we have things sorted here. And what we find is we have 64% artistic for the matches. The background is what we're doing is we are making an inference. The data gives us which bacteria are more often seen or less often seen for each cohort, like for autism. Now, we're making an assumption that if they are less often seen, their percentile ranking, the numbers they have, will be generally less. If they're seen more often, we would expect the numbers to be seen to be more. This is experimental. So we go there, we click on that little thing, and we go over, and we have actually 210 items. 65% of them are matches in terms of the shift rate. For example, just one is a match. The reference data set has it's seen less often. They're at the 17th percentile. Yep, we'll mark that one. Number one, less often, down to 3 percentile, almost disappear entirely. So we can mark that one. Number one, less sick, down at 0 percentile, which means probably between 0 and 1. Number one, and number one, which is less, and number one, which is less. Let's get that. Check, 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 check. Excuse my sloppiness. And we can go on, and I'm just going to do the genus level, but you can see that we have a very strong, interesting combination there, and we can go on to the next page. And actually, let's go that far, and now we just click add to Handpicking bacteria, and then when we go back, we should see Handpicking bacteria sitting here, and we can go and view the bacteria picked, and there they are. We can go back and also go and find ourselves again and go over to Handpick suggestions, which goes over there. We're doing it at genus level, and what we can do is just go and click view, and we now get a list of suggestions being done for it. So that's is how we go and get our numbers coming in and work from there. Again, everything is this is experimental. It's running with a concept and seeing what happens. So that's the basic ways of doing it. The large scale thing would be also to go and go back and go to the same one. Which is down here. And what we could do is we could go and using advanced suggestions, we go and select autism, which is here. Same sample, go through and see what suggestions are, and the suggestions are sitting there. Now we can flip. Oh, okay. Okay, I closed the area window. So we have rice bran, vitamin D, plantarum. Over here we have a slightly different combination which is the second way through. We could also go and do a third way through, which the third way goes up to explore symptoms versus bacteria summary. Go down, find the one you're interested in. In this case, we'll click here, and then we see the matches there, and we go and we now see we have a bunch of secondary suggestions. I always prefer primary suggestions, but that is a very significant list there. So we can go through and proceed your hand. Okay, let's try keeping it to be fair with everything else. We're going to keep it to genus level. And I've checked there, and something I've noticed, a minor bug, as in some of the light bulbs disappear when change pages. So, okay, this is illustrated. I'll figure out what the problem there is and get that remedied. And so now we go through here. And we can go through and get suggestions there. And one or two of the items are recognized from our list, so we end up with actually 3 lists. Now we can go over to the consensus report. And what the consensus report, it takes each one of all the suggestions which have been generated for one specific sample in the last 24 hours. Suggestions are aged up and disappear after 24 hours. Put them into one big list. What we have is, at the top we have 60 items. All these items will shift the bacteria in the right direction based on studies, and none of them will shift any of the bacteria, any of them, in the wrong direction. In terms of that. So in other words, what we have is we have a very safe combination. For example, piston is one item there, which comes in. Actually, let's go and sort them by value and find out what the highest one is. Okay, we have variety. Hypochlorite. Okay, we have variety of thing. We have nuts, and pistons is an interesting one. When looking for fiston and autism with no luck, then I went and looked at fiston and neurological things and immediately found a study. Basically, it has a neuroprotective effect on the mitochondrial Parkinson's disease, which means it will probably also have benefits in the case of autism. We don't have any clinical studies on piston and autism, but the suggestion that it may help a neurological issue seems to be broken out by some evidence as seen here. Another Pubmed study saying, excuse me, neurological disorder is now a definition of autism. So, well, I cannot find something explicit on Pubmed dealing with this and autism. I find a lot of references to the class of illnesses autism falls into. Going back to the consensus suggestion, which arise from processing the microbiome in different ways, trying to select different bacteria and different types of shifts to process, you get a list of suggestions, which often you will find comes up with suggestions which you can find supporting literature on PubMed, saying that it has a better than average chance of helping. And why it helps? Because it contradicts the bacterial shifts that is causing some of the symptoms of autism. It's not a cure for autism, but it is a mechanism for reducing the severity of symptoms. So we have things, some things are easy to implement, like start using safflower oil, excuse my twisted tongue, pulse as a food, assuming your kid isn't too picky, ferric citrate, which is iron supplement, and it will do, high beef diet, salt, which of course has pros and cons, other types of diets shows up as being there. And as always, due diligence in terms of checking up. Here is another one, which is sometimes referred to as W. It's a Japanese probiotic, something like Brewer's Yeast, but different. But it does come in with a pretty good score. Okay, so let's take it from the top. Microbiome prescription. Once you uploaded a 16S sample such as Thrive or Ombre, I think it's now called, or Biomosite or anything else that gives us a uploadable definition of uploadable, you can see here. Any of these ones here are first class things. We have second class ways of doing it, which you don't get as much information, but it's better than no information. And worst case select, you can go to other lab analysis, which are second, actually more like third class uploads. And all those, the upload is not done as uploading of a file, but by going over, let's take a look at GI map. By going and marking whether or not the GI map reported high, very high, extremely high, low, very low, etc. So you have to transcribe the data. Now, I have included here, it is hobbity gobbledygook, a site problem. I work NCBI taxon numbers with a specific name usually being assigned for most stuff. Often on third-party reports, they use a different name. So what I have is have all the other names known for just one particular bacteria. So if you can't find on the list, remember Control F to try finding it on the web page. If you can't find it on the, you should be able to find it using Control F, and you should be able to identify where it is and make the changes. I'm sorry, but there's a major problem with standardization between reports and science and medicine, and I simply tried making things as easy to resolve as it's possible. So once you get your data in, you can proceed to select data based on criteria. This time we did it by 3 ways. One is we did using Pubmed Bacteria associated with autism, which you can always take a look at directly, and Pubmed conditions. Put down here the autism. Over here is list of bacteria, where it's high and too low, and over here we have, for example, let's click this one. We'll have the studies which this information comes from. So you can actually go back and double check that I haven't made the data into error. Very possible. I'm not perfect. I don't have staff to double check the entries. I would love to have staff to do that, but that takes time and money or commitment. So you can filter by the bacteria which are associated, would be too high or too low. We look at the number in the sample. Is it a match or not a match? If it's a match, we select that bacteria. If it's not a match, we simply ignore it. Because there are multiple subsets in autism of different people with different characteristics and symptoms, and the microbiome are distinctly different. This is a catch-all, and we simply look for, okay, we have a match here, we have a match here. We don't care which subset it is, but you do match each part of one or more subsets, and we're working from there. Second way is by using citizen science, which is once the sample size gets large enough, probably be as accurate or more accurate than here. But it, of course, has some interesting challenges to it too. The endgame for citizen science, click on Explorer, Symptoms versus Bacteria Summary, and you can actually sub-select for a particular characteristic. And over here, indicates how many relationships we have found, which appears significant. They may not actually be how big the sample size. Some gets a horrendous number probably because this particular subset tend to have the same bacteria shift, and hence we get a very strong one. And For autism, we have a rather good number. We have 14 different groups and subgroups, which diagnosis we have the most. And then we have subgroup with various number. High functioning autism has 18. So you can take a look at that. And if you're high functioning, you may want to be even more high functioning by correcting the shift seen there. Here, and then we have information coming through and where the matches again. We have a few matches, but none of them are strong. The strong ones will automatically be checked. And so you go through, you generate suggestions. You can look at the suggestions one by one, or you can just go through a stack of different ways and look at the consensus report. Key thing about the consensus report is the very top one, the safest of ones are which we have no information of these items pushing things in the wrong direction, but we know it will push things in the right direction. And that's covering generally dozens, sometimes many dozens of bacteria shifts you're trying to correct for. So it makes it a way where you can do an in-depth analysis and get a consensus list from it, so that you don't have to figure out now which way is the right way of doing it. You do all likely ways, and the consensus report is a consensus of all the likely ways sorted and gives you a conservative list of substances to try or in some cases to avoid. Okay, I think I'm going to shut up now, and that's enough for the moment.